Welcome to myprojectbazaar.com. Our project title is Joint Optimization of Lifetime Under Transport Delay Under Reliability Constraint Wireless Sensor Networks. Abstract. This paper first presents an analysis strategy to meet requirements of a sensing application through trade-off between the energy consumption and source to sync transport delay under reliability constraint wireless sensor networks. A novel data gathering protocol named Broadcasting Combined Multi-NAC ACK protocol, that is BCMNA protocol, is proposed based on the analysis strategy. The BCMNA protocol achieves energy and delay efficiency during the data gathering process both in inter-cluster and intra-cluster. In intra-cluster, after each round of DDMA collection, a cluster head broadcasts NAC to indicate nodes which fails to send data in order to prevent node that successfully send data from retransmission. The energy for data gathering in intra-cluster is conserved and the transport delay is increased with multi-NAC mechanism. Meanwhile, in inter-clusters, multi-acknowledgement is returned whenever a sensor node sends any data packet. Although the number of acknowledgement to be sent is increased, the number of data packets to be retransmitted is significantly decreased, so that consequently it reduces the node energy consumption. The BCMNA protocol is evaluated by theoretical analysis as well as extensive simulations, and these results demonstrate that our proposed protocol jointly optimizes the network lifetime and the transport delay under network reliability constraints. Let us see the flow of our project. First, network deployment is done. Then we have to select the random waypoint model for mobility, and we have to implement the BCMNA protocol, that is our multiple negative acknowledgement and acknowledgement protocol. From that we have to select our cluster head. It is selecting based upon the energy. The node which have the highest energy is selected as the cluster head, so it is selected dynamically. If the sensor node is in particular region, so it registered via that cluster and data transmission is done. We have to evaluate our performance based on 4 parameters, that is energy, throughput, delay and packet delivery ratio. Let us see the output of our project. First, to open the VMware workstation. In that, click the terminal window which is bottom of that taskbar. From that, first changing the directory which we have that code. This command is used for running our TCL file, that is our tool command language file, ns space main.tcl. There is ns space file name.tcl is a syntax. This is our time slot, and other is TDMA scheduling process and the updated energy informations. The cluster head is selected depending upon this residual energy, that is updated energy. After it finishing, it shows our simulation result graph and the NAM window, that is network animator window. This is our output window called network animated window. When we click on this play forward button, it will works. This is for increase the speed. So in that, our network have 100 nodes. So 4 regions are formed, 4 clusters are separated, and 4 nodes are selected depending upon the energy. In this region, each region have 25 nodes, and in each region have each node have their own energy. From that energy, the node which have the highest energy is taken as the cluster head. So now 38, 73, 98 and 23 is taken as cluster head in each cluster. 99 is act as a base station. Now the data transmission is done. So this is our TCP connection we use for communication. We use TCP, that is a transmission control protocol, and how much byte it sent is displayed. The transmission is done parallelly in each clusters. So the node which want to send the information to the base station is send the information via that cluster head. So it is denoted in this place. So this node is act as a cluster head, that is 98, and this 79 node sends information to the cluster head. So finally it sends information to the base station. So our process is BCMNA process. So this is implemented in this place. Finally it sends information to this base station. There is 77 node, 77 gives information to that node 99. This is our simulation result graph for this is our packet delay. So existing system achieves more packet delay than our proposed system. So we achieve better delay tolerant environment. So packet dropping ratio for existing system is higher than the proposed system.